For the next two problems, we're going to look at trying to find the error in someone else's work when they try to reduce these rational expressions. And so Jesse tried to reduce the following expression to lowest terms. This 3x squared minus 9x over 7x minus 21. And this is his work. And remember the general strategy. You want to factor the numerator and factor the denominator and see if you can make some cancellations while also determining which x values you need to exclude from the domain. Since remember that certain x values lead to division by 0. So Jesse started his work by factoring the numerator, this 3x squared minus 9x, and set it equal to x plus 3 times x minus 3. And this is already the mistake. These are not going to be equal. But let's just work through that ourselves. So if we had 3x squared minus 9x and we want to factor this, so notice that each term has a multiple of 3, so we can factor a 3 out, and each term has a multiple of x. Namely, they're each divisible by x. So we can also pull an x out. And by pulling or factoring out this 3x from the first term, we're essentially dividing it by 3x, and so we'd be left with just x. And here, dividing this by 3x, the x's cancel, and 9 divided by 3 is 3. So you'd get 3x times x minus 3. And you can see this is not equal to x plus 3 times x minus 3. Since you can look at it from the other side, x plus 3 times x minus 3, if you multiply this out, that's x squared minus 3x. And we get plus 3x minus 9. This is a difference of 2 squares. And so the middle terms are going to cancel out, and you get x squared minus 9, which is definitely not what we started with. So for these problems, you're going to have multiple choice to be able to find that mistake, and you would see that Jesse made his mistake in factoring this numerator. And of course, you can verify that that is the only mistake by going through the rest of it. Factoring the denominator, notice you can factor out a 7 from each of these, and you're left with 7 times x minus 3, which you can verify by just redistributing. So that step is correct. And also, the denominator has to have 3 excluded from its domain of values. Since if you plug 3 in here, 7 times 3 minus 21, this is just 21 minus 21, this would be 0. And that would lead to division by 0, which we can't have. So these steps made sense. And then reducing the lowest terms, well, the numerator is not factored correctly, but assuming this is correct, which it's not, but if we make the assumption that it is, you would be able to cancel out that x minus 3, and you'd have x plus 3 over 7. But of course, our numerator is over here on the left side, this 3x times x minus 3. So you'd still be able to cancel out the x minus 3, but instead of this being x plus 3, this would be 3x here. And so our final answer would really be 3x over 7. So with these problems, you have two choices. You can either just go through step by step and verify if something is true or not, or you can do all the work yourself and then go back and double check your work with their work to try and figure out where the mistake was. So both methods are perfectly valid, and I encourage you to try both of them. So let's go on, and we'll try another one just like this. And in this one, we have Lindsay trying to reduce the following expression to lowest terms, just like the last one. And for this one, we'll work out the problem ourselves and then compare it to her work and see where the mistake may have been made. And we can just rewrite it. So x squared minus 9 over this 2x squared minus 6x. And remember, the general strategy for these is to factor the numerator and the denominator and then determine which x values are excluded from the domain. So notice the numerator is a difference of squares. We have x squared minus 3 squared, which we can factor into x minus 3 times x plus 3. So that will be our numerator now. And our denominator, notice we can pull out a greatest common factor. They each share a multiple of 2, and they each share a multiple of x. So we can pull out a 2x, and dividing 2x squared by 2x would leave us with x, and minus 6x divided by 2x would be minus 3. And you can double check that you're doing this correctly by just redistributing in both cases. But we'll assume that's correct. And from here, we can determine which x values are not in the domain. If you plug in 0 here, you get 0 times negative 3, which is 0. So 0 doesn't work. And if you plug in 3, you would get 0 here times 6, which again is 0. So 0 and 3 are not included in our domain. And now we can simplify this by noticing that you have x minus 3 in the top and in the bottom. So we can cancel out that x minus 3. And so we're left with x plus 3 over 2x. So with that in mind, we can go through and see where she may have made a mistake. So factoring the numerator, she did that correctly since it is a difference of squares and we got the same answer here. Factoring the denominator, she pulled out the greatest common factor of 2x and was left with x minus 3, so that's right. Now the excluded values, looks like 0 was excluded, and she excluded plus or minus 3. Now this is where the mistake is. Since it is true that we need to exclude 3, but we don't need to exclude negative 3. So it should only be that x cannot equal 3. Since if you plug negative 3 in here, in your denominator, you would get negative 6 times negative 6, which is just negative 36. Excuse me, positive 36. And so that is perfectly fine. You would actually get a value. Now, I think the reason that she made that mistake, and many students will make this mistake, is that in the numerator, if you plug in minus 3 up here, this term right here would become 0. And so your numerator would be 0, and you'd have 0 divided by 36, which is equal to 0. Remember that you can have 0 divided by anything, we'll call it a, and that's just equal to 0. But if you take some number and divide by 0, this is the one that's undefined. We cannot divide by 0, but we can take 0 and divide it by anything. So with all of that in mind, the only mistake she made is that she excluded a value that would technically be in the domain. And another way to think about it is that an x value is in the domain if you can plug it in and get a y value, and then you can graph that point.